Hello everyone and welcome back to another episode of the Hidden Quantum Champions. Today we are looking into a company called QBoson from China that is working in photonic quantum computing, and if you are interested in where they actually already are and what is their roadmap towards the next years of development, then stay tuned for today's video as we are diving deeper into QBoson. But maybe before we do so, let's take a step back and talk about the idea of photonic quantum computing. So photonic quantum computing is the idea of using photons, which are the quantization of light. So light is behaving like a wave, right? But it is an electromagnetic field excitation. So it has electromagnetic properties, and it can be quantized into single particles or into single energy portions called photons. You can separate them, so then you can throw them at a double slit, for example, and they will still interfere with themselves. That's this so-called duality, right? The quantum, so the wave-particle duality, because you can only quantize it down to this, let's say, small energy portions of photons. So there's not something like half of a photon or something like that. It's really the quantization of light. But then on the other hand, even if you just have a single photon, it can still interfere with itself if it goes through a double slit, for example, and that's what is considered, or what is called, the duality between particles and waves. And that also creates already the transition to the idea of quantum computing, where you're using superposition and entanglement of a quantum particle or a quantum system to basically do information processing. And as photons are quantum particles, you can basically do exactly that with them. So for example, if you think about the double slit, this is a way to create a superposition between the photon going through the one slit and through the other slit. So it's basically living in a superposition, and therefore it's interfering with itself. You can also entangle photons with each other. So if you, for example, think about an electron and its antiparticle hitting each other, they will annihilate. So they will basically resolve themselves into energy. They will vanish as particles, but they will emit two photons in the opposite directions, and these photons, they are entangled with each other in, for example, their polarization property. So if one is polarized one way, the other one is polarized the other way, and that's just the nature of it. That has to do also with the conservation laws. You don't know exactly which photon is polarized in which way. Therefore, if you measure one, you know the property of the other one. That's why they are entangled. This is now just two examples of how photons can be entangled and in superposition. And of course, now you can scale these ideas into something that is becoming a quantum computer. So you have to fulfill the so-called DiVincenzo loss criteria. This is a set of criteria that a quantum system has to fulfill in order to work like a quantum computer. But if you can manage to solve these, to map these onto your quantum platform of choice, superconducting qubit, spin qubit, ions, neutral atoms, photons, then you can basically build a quantum computer with those. Now, this approach that QBoson is taking is not unique only to them. There are also other players around, like for example, here in Europe, we have Candela, which is doing great work using photons to build quantum computers. And there's also PsiQuantum, for example, in the US. Now, back to their website and back to what they are working on and where they already are. So here we are now on their website. It says, lead quantum computing with practicality, redefine artificial intelligence with quantum. We see this nice animation here in the background where you can hover with the cursor. And then it says, both quantum focuses on the technical root of coherent quantum computing and optical quantum computing, committed to the full platform research and development and industrial landing of various types of software and programmable optical quantum computing, establishing upstream and downstream ecological chains and industrial chains, and continuously improving the calculation of quantum computing for various problems such as AI, big data, biomedicine, and so on. Fast applications to meet the quantum power needs for the future era and size of world's cutting-edge hard technology development. By the way, I always say that because sometimes gets people confused. So I just translate the website with the browser translation. So it's originally in Chinese. My Chinese is not good enough so that I cannot really read anything there. I maybe know one word or two. And that's why I, of course, need the translator, and also because I need to be able to share things with you. But sometimes it translates things a little bit odd. So if a sentence might seem odd and off, that's not because of QBoson or Bose quantum writing something odd, but it's probably just getting lost in the translation. Now back to the website. So open a new chapter of optical quantum computing, closely in line with the 15th 5-year plan. The self-developed special quantum computer adopts advanced coherence optical quantum technology, which can achieve stable operation at room temperature for 7 times 16 hours, which greatly reduces the cost and complexity of quantum computing, with a processing capacity of up to 3000 qubit problems. It is specially designed for high precision simulation and large-scale data analysis, aiming to provide enterprises with unprecedented computing speed and efficiency. And here we see one of those systems. The ongoing quantum revolution, so our quantum computing solutions are promoting technological innovation in all walks of life. These achievements are not just numbers, they represent our solid footprint in every step of exploring unknown eras. And then here you see 9000 watt plus, 100%, and so on and so forth. I guess we will learn more about that later. So, provide solutions for complex worlds. With the development of quantum computing technology, it is gradually becoming the core force to promote innovation in many industries. From improving the train efficiency to artificial intelligence models, to accelerating the research and development of new drugs, to optimizing urban resource management, the application potential of quantum computing is almost unlimited. We focus on developing solutions for specific industries to help consumers unlock the huge business value and technological breakthrough brought by quantum computing. And here are 3 examples, right? Biopharmaceuticals, artificial intelligence, and smart city or digital city. So in the biopharmaceuticals, molecular simulation revolution, so accurately simulate complex protein folding at the atomic level, compress the research and development cycle of new drugs from year to month, and accelerate the innovation of saving lives. Artificial intelligence, so quantum machine learning accelerator, the training time is shortened from days to hours, breaking through the bottleneck of AI model parameters and unlocking the new paradigm of multimodal fusion analysis. And then smart city or digital city, urban neural network, real-time optimization of urban traffic and energy distribution system with tens of millions of variables. And I mean, these are typical applications that we've also seen with other quantum computing companies that they are targeting. Oftentimes beside that we have smart grids, we have financial applications, there are also material research applications broader than just pharmaceutical, like discovering new materials, developing, new materials for batteries, for defense applications, and so on and so forth. Here we see these very 3 specific ones. Then quantum creativity within reach. So inspire creativity from the developer competition, join the active developer community, build an algorithm model through the intuitive Kaiwu SDK, then verify the performance on the quantum cloud platform, and finally deploy it to the physical quantum computer to solve real-world challenges. One-stop quantum development lifecycle allows every developer to call on quantum computer. And then we see here quantum computer developer competition, open the developer community, SDK, software development kit, and then the cloud platform, so the full stack. By the way, I mean, as per usual, if you want me to go check this out, or if you want to check this out together, I think it would also be fun to have, let's say, a global community entering, for example, this software ecosystem here and playing around a little bit. Then, let me know down in the comments below. I'm always open for that. I'd be very happy to explore together with you what we can do and how we can how we can play around with these systems and learn together about quantum computing and quantum algorithms. Now to the roadmap. So our quantum computing roadmap, we are committed to building a fully connected large-scale quantum system to transform quantum computing from theoretical advances to real-world application value, which is the core path of our software and hardware collaborative development. It starts in 2023 with the QCD Gen 1 with 100 qubits. So now we are in 2026, right? 3 years ago, it started with the first system and 100 optical qubits. Then we see here the QCD Gen 1 performance upgrade to 550 qubits in 2024, increase the intelligent control system, improve operation and maintenance efficiency. Then we see the Gen 2, which has 1000 qubits in 2025. So last year, accelerate the time of system evolution. Now we are in 2026 as I'm recording this video. It's CQD Gen 2 performance upgrade. So intelligent parameter adjustment strategy, improve shot efficiency, chaotic amplitude control, solve quality improvement, and classical computing power improvement, so reduce post-production time. That's going to take until end of next year, 2027. And then in 2028, they are planning to move to the generation 3. You see that from here on, we also don't see numbers of qubits anymore in the commitments. In the Gen 3, it says new pump control scheme, so quantum classic fusion, heterogeneous computing cluster. So I guess this is moving into, let's say, server sizes and then compute center applications. Then the Gen 3 performance update, multi-core parallel, and then the CQH quantum optical computing chip is for 2030 plus. So that's then basically incorporating everything into a single chip. Practical quantum intelligent future. So every algorithm optimization and every industry breakthrough comes from our insistence on practical value. When quantum computing meets artificial intelligence, we are no longer satisfied with gradual improvement. We are redefining the boundaries of intelligence, leading the quantum computing revolution with practicality and making powerful computing power severe the needs of industry development. And then we see this nice animation down here, and as per usual down here it says some information about the company, including the fact that they are based in Beijing in China. Good. Now let's quickly check back the hardware products that the company is offering. As of today, there's the Shanghai 1000 that we've seen before. So Bose Quantum Control Shanghai 1000 dedicated optical quantum computer has 3 working modes: standard precision and overclocking, which can be flexible, selected according to different scenarios, and can support up to 3000 qubit problems. Equipped with a higher level intelligent control system, it can realize real-time monitoring and automatic calibration of core instruments. There's further information which unfortunately is kind of hard to read with the translator, but that's just to say. So there's this product. There's something here about 1000 qubits. So the only kilobit quantum computer in China that can run stably for a long time. Bose Quantum's 1000 qubit coherent optical quantum computer has stronger compute power, higher fault tolerance, broader application prospects, and stronger stability. There's the 550 that we've talked about before, right? So this is the second product, the boost of the Gen 1 product that they have, right? Coherent optical quantum computer 550 realizes the 550 node fully connected programmable max cut problem coherent optical quantum calculation solution for the first time in China. It can search in a huge solution space within a few milliseconds to find an optimized solution. It has achieved tens of thousands of times faster than classical computing in practical application problems. And here's the 100 qubit computer. Average solution results is 120 times faster than on the classical algorithm. That was, I guess, the first product, the first proof of concept that they were delivering. All with very different and very unique designs, I would say. And then, okay, let's see. So what are the components, I guess? There's the core modules, here. So high precision quantum computing, special optical fiber constant. Constant temperature control equipment can stabilize the temperature change of the optical fiber within 0.001 degrees Celsius and maintain it for a long time, efficiently avoiding the error of optical fiber length change caused by temperature fluctuations. At the same time, the equipment also has a special vibration isolation design which can effectively avoid the impact of environmental vibration noise on optical fiber. By the way, these carousels, they're always a bit annoying. I've had that with multiple of these pages now. They're always flipping way too fast. Can somebody please read through the text once out loud and make sure that they are not, let's say, flipping so fast, because it's really hard to show the websites if that always keeps happening. So next thing is the quantitative is an intelligent system especially customized for coherent optical quantum computers that integrates optical quantum measurement feedback, system status detection, computing progress control, process control, and other functions. It mainly includes control calibration module, high precision optical quantum data sampling module, high speed signal modulation module, high stability power supply module, radio frequency, synchronous clock module, and optical detection and measurement module, and so on, which can independently import the calculation matrix at gigahertz regulated rate and control read and execute up to 100 times faster feedback at the same time. Optical quantum bit, and it realizes the full connection control between hundreds of scale optical quantum, thus making the Tianzhong quantum brain have complete programmable capabilities. So this is basically the source, right? The information source, and then we see here as the next one, the laser beam with a frequency of 2 omega acts as a pump light and is incident on a nonlinear optical crystal. After the resonant cavity oscillation, it will output 2 beams of signal light and idle frequency light with a frequency of omega. The polarization direction of the 2 beams of light is the same, which is called simplified optical parameter oscillation. In the process of oscillating of the two output light pulses, the state of these 2 beams of light is in the compressed state of light quantum mechanics, which can be used as quantum bits in quantum computing. So there you have the light sources, you have the electrical sources, you have the light sources, and then you have basically the fiber part, right? Now the next thing is this one here. So using a special high-speed pulse generation device and optical chopping technology, ultra-narrow line width continuous laser is modulated in high-frequency pulse laser output, and narrow line width laser amplification technology is reused to produce a low noise and high power base frequency light source. So that's the laser that is producing the light. Then the next thing that we have here is the quantum frequency regulator, is the core component of quantum computer. It adopts a combination of lock-in amplifier and PID closed loop control to realize quantum through high frequency data signal modulation, phase sensitivity detection, error signal extraction, and feedback adjustment and other operations. The key instrument for the preparation and control of the state ensures the accuracy and stability of quantum computing and provides stable and reliable support of high-end applications such as quantum computing and precision optical measurement. So that's basically the measurement unit, right? And then I guess here we have something like either the detector or the waveguide. So the PPLNOY waveguide can be used for efficient wavelength conversion. In the C-band, the micro-nano processing technology we adopt can achieve double-ended optical fiber coupling, which can still ensure low insertion loss. The polarization across a process can also achieve periodic polarization field structure of almost one-on-one, laying the foundation for efficient nonlinear optical conversion. At the same time, the support temperature control module has a temperature adjustment range for room temperature up to 120 Celsius and zero. The precise temperature control of 0.001 Celsius ensures the stability of the PPLN waveguide output. So this is basically, I guess, to couple the different units. The C band is the typical communication band that telecom providers are using today in their optical systems. Okay, I mean, this I think we have already more or less seen. Let's quickly check out the different solutions that they're offering. We've talked about these before, right? There's the biopharmaceutical solution. Then we have some artificial intelligence and some digital city applications. I will look now at the biopharmaceutical in a bit more detail, and the other ones we do very quickly. So quantum plus biopharmaceutical solution. The core link for drug research and developments is to identify and develop molecules that help treat diseases, and quantum computing can predict and simulate the structure and behavior of molecules more efficiently than traditional computing, shorten the time to drug screening, and greatly save the cost of drug discovery. And then we have this beautiful animation here in the background. It says Tiangong Jishi simulation platform, so quantum computing plus AI plus virtual screening. Both quantum provides a new test-driven high-efficiency drug design platform. Here we see the different steps, so molecule design, protein folding, then you have the simulation platform and the performance comparison as well. Public health, so virus evolution mutation simulation, so master nature, transcend nature. The coupling characteristics of the fully connected network topology excavate the key co-evolution information and sequence, and then energy sampling, rapid reasoning sequence evolution direction. So that's basically on the molecular discovery side of things, I guess. Oh, interesting. Then we have the analysis of quantum plus life cycle systems and individual energy, so superiority is reflected. Okay, then we have quantum plus drug development, metamorphic slopic identification. Okay, and then down here quantum plus material discovery. So I guess that's a bit more broader. Okay, well, let's quickly also check out the other ones, just so we have seen them as well. Oh, not sure what's happening here. I think the animations make it a bit slow. It looks very nice, but somehow it's not super easy to click. Okay, these are also a bit more shorter. Okay, so here we have the AI part, and then there's something on the digital city. Okay, I mean, yeah, just for you to have it seen, and for me as well. I see typical things like here, like sub-QBo. So QBo is a classical algorithm that is being used in the optimization space. Sub-QBo, I guess, is then in a sub-version of it. So I guess you can run very well optimizations problems on it. There's the community, just to quickly check it out. So we've seen it as well. So let me quickly turn on the translation again. Here we are. So this is now the developer community. So you see here, there's like articles available as well, videos, questions and answers that are happening. There's Learn the Map. Not sure what this is. Singularity project, quantum computing cloud. Oh, okay. So you can there create some accounts. There's articles, activities, even a PyTorch plugin. So PyTorch is something that a lot of developers are using in the field of machine learning. So programming and training their own kind of learning architectures. And this is basically something that is available here as well. There's the cloud platform, the Join Us and Enterprise activities. For me, let's quickly jump on the About the Company page, just so that before that, let's quickly check out the news articles. I'm recording this video in May of 2026. You can see here the last article is from March, end of March 2026. So I would say reasonably up to date. It says Bose Quantum was reported by News Network, China's Future, and so on and so forth on March 17th. Okay, now let's quickly, as per usual, also check out the company page and see what the company is, let's say, saying about itself, as we are then wrapping up today's video. So, about Bose Quantum. Beijing Bose Quantum Technology Co. Limited was established in Chaoyang District, Beijing at the end of 2020. It is a hard technology company focusing on optical quantum computing. The company's core research and development team comes from Stanford, Tsinghua University, the Chinese Academy of Science, and other well-known institutions at home and abroad, and has many years of experience in optical information research and has applied for dozens of innovation patents. At present, 70% of employees are engaged in research and development, and 65% are master's degree. Since its establishment, Bose Quantum has completed multiple rounds of financing and released a new generation of 1000, qubit quantum computing quantum bit coherent optical quantum computer in May 2025, and the technology is at the world's leading level. Optical quantum laboratories have been built in Suzhou, Shenzhen, Nanjing, and other places respectively, and China's first large-scale special optical quantum computer manufacturing factory has been built in Nanshan District, Shenzhen. Scenario verification has been carried out for artificial intelligence, biopharmaceuticals, finance, communication, energy, and other fields, and continues to attract top talents aiming to use practical quantity. With subcomputing as the core, we will build a full-link industrial ecological innovation system and explore new paths for practical computing for industry, academia, and research applications. So that's, let's say, the background on the company. So you see a lot of people from different places, Stanford, Tsinghua, and the Chinese Academy of Sciences. So let's say premier Chinese and American universities. You see there's a lot of researchers working there as well, a lot of research output, but then also moving towards, let's say, productionalization. There's this manufacturing factory in Shenzhen. So it's, let's say, scaling up as well. Vision, lead quantum computing with practicality and redefine artificial intelligence with quantum. Core values are customers first, win-win cooperation, continue to innovate and climb the peak, have the courage to take responsibility and establish a sense of career, community, trust, and respect everyone. Be down to earth and adhere to result oriented. Then here you see again the roadmap. We've looked at this before. So it started, I think, in 2020 with the first quantum, or maybe 2021, I don't remember exactly. So there was the first quantum computer, right? You can also see here joint publication results of quantum finance with Huaxiang Bank and People's Bank of China. So you see that also already there was some interest from the finance institutions. Now we are in 2026, and here it says Bose Quantum tops light, thick accumulation, and thin hair. The top journal publishes special quantum computing, the foundation of the academic framework. Then Bose Quantum Computing Cloud Service is launched on Alibaba Cloud and Huawei Cloud, double cloud parallel, open to the world, facing the international quantum computing competition. And then Bose Quantum Global Open Source Kaiwu SDK Community Edition, creating a quantum computing toolbox that everyone can customize. And yeah, excited to see what else we will see in this year and how it will then move on in 2027 as the company is developing. Team introduction. So since the establishment of Bose Quantum in 2020, Dr. Wen Kai, the founder and CEO of Bose Quantum, Ma Yin, the founder and COO of Bose Quantum, Dr. Wei Hai, CTO of Bose Quantum, and Professor Wang Chuan, the chief scientists of Bose Quantum have led the technical focus to the technical team to focus on the research and development of practical quantum computing equipment and are committed to coherent light quantum computing equipment, engineering realization and application exploration of preparation. In April 2024 and April 2025, 550 and 1000 qubit coherent optical quantum computers have been realized and released, reaching the international leading level and successfully carrying out application exploration and real machine verification in finance, transportation, communication, biomedicine, and other fields. As per usual, for the Chinese ones, we see here the honorary rewards and including some certificates, I guess also some patents. And then down here is the enterprise news section that we've already checked out before. Besides that, there's of course a call to action to join them. There are different, let's say, positions apparently open. And I think with that, we are already reaching the end of today's video. As per usual, if you found that interesting or if you want me to check out more companies from China, from other specific countries, then let me know down in the comments below. I'm very happy to do that for you. Also make sure to subscribe to this channel. If you have watched all the way to the end of today's video, there's a high likelihood that you will want to watch another one. So make sure to subscribe. And as per usual, see you in the next one and stay hydrated. Until then, bye-bye.